We do this SSL TLS dance for a while now, and it was a political, why did they rename SSL? It was politics, apparently. SSL 1.0 was internal to Netscape, 2.0 and 3.0 released publicly, and then SSL 3.1 essentially became TLS 1.0, right? And it's essentially the same protocol, just better. Better ciphers, better encryption choices, it's the same, but now I have to do this SSL TLS dance and I stumbled earlier on that. So today you're using probably TLS. They should have called it TLS 4.0, not 1.0, because some dumb admins think 3 is greater than 1. They use SSL 3 instead of TLS 1, because 3 is greater than 1. It's like, no. 1.2 is now very dominant. 1.3 is now out, right? And 1.3 is a significant improvement. We talked about you can no longer passively intercept it. You can technically actively intercept it. That thing I did with the blue code I talked about, where you have to touch every client, import the proxy cert into every client, and technically 1.3 is proxyable, but it's very, very difficult to do so, and no commercial vendors that I'm aware of can do it. Because it used to be TLS 1.2 and older, the client could say, I want this encryption, and the server says, well, how about this encryption instead? And the client's like, okay, fine, I support that too, right? I want X, you give me Y, but I support Y, fine. Now the client says, I want X, TLS 1.3, it's getting X. You can't change it. So the server can't say, you know what, how about this? So in other words, the proxy has to support every single cipher that the client might ask for, and there's dozens. And no commercial vendors there that I know of yet, right? So what they're doing now is they're downgrading you to 1.2, which is working today, but may not, at some point it's not gonna work, right? And passive is gone for 1.3. Here's a handshake. I say, hello, I wanna talk SSL TLS with you. There's a little dance again. Server says, fine, here is my header, my X509 cert. So it sends you this. So I'm on twitter.com, and I go to certificate, I go to the details. There's the X509 cert, right? And it's a bit hard to see here, so what I'll do is I'll screenshot it and blow it up a bit. That's the actual cert. Blow this up a bit. So they're using DigiCert, there's the name, blah, 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 blah. You get the idea that there's a chain of trust here, right? Basically, your browser and or OS has a list of a few hundred trusted root CAs at the top of that tree, right? And your browser and or OS creator have decided on your behalf to trust these X 100, 300, 400, 500 CAs, certificate authorities, right? You can change that list. Some of my more paranoid clients do change that list, remove things. If you're with DoD or .mil, you probably added things in there. The DoD root cert is not in browsers natively. It's gonna be added, right? And below that is the private key. And public key, sorry, I misspoke, public key. There's the public key. So that public key, now I'm gonna give you a real crash course in asymmetric encryption right now. Real crash course. It turns out asymmetric encryption uses 2 keys, one to encrypt and one to decrypt, right? And if you encrypt with public, you can decrypt with private, right? You give the whole world your public key, right? The private key is held privately, obviously. So what I do then, when you hand me that key, I generate a random symmetric session key, encrypt it with that key, send it to you. You then decrypt it, now you have the same session key, because the server has the private key configured locally, right? So I have the public key right there for Twitter. I can encrypt anything I want with that, including another key, a session key. Send that over to Twitter. Twitter uses its private key to decrypt, and now we both have the same key. Once you encrypt with public, you cannot decrypt with public, only private. That's a super crash course in asymmetric encryption right there, right? That was a real rush, but that's how it works. And why do we use both? The session key is symmetric, meaning like AES or something. This is asymmetric. So why are we using a session key that's symmetric? Well, symmetric encryption like AES is faster and stronger than asymmetric. This is great. Up until this technology, strangers cannot communicate without pre-sharing something, a key or something. This allows strangers to communicate without pre-sharing anything, right? This was the revolution of the 1970s, RSA, Diffie-Hellman, it changed the world, right? Strangers, including criminals and terrorists, can now communicate having never met each other securely in ways that nation states can't easily decipher, right? And so the asymmetric's great for doing that, but it's actually slower and weaker than, say, AES. So we'll generate a random AES key encrypted with this, server decrypts, right? Also, there's a chain of trust, a bunch of other stuff. It's signed, a bunch of stuff happening. That's an X509 cert, right? So download the X509 cert, generate the session key, encrypt it with the public key, send it back. Server decrypts, we both have the same session key. Off we go. SSL TLS primarily thought it was providing confidentiality. It does more. And it can do block data encryption. It does integrity. It does hashing, things like that. And we want to test SSL because there's a lot of complexity here now to test, right? This can become attack surface, right? So public key certificate authorities were only as secure as our least secure CA, at least until certificate pinning. Oh, who was it? Google just revoked a whole bunch of, were they semantic license, CA, X509 certs? Google just revoked a whole bunch of stuff. So Google plans to formal plan to distrust semantic certificates in 2018, as did Firefox. They followed suit. Firefox is very, very hawkish on this front. They're very, very progressive on any of this kind of stuff, right? So what if instead of putting an untrusted cert on the SSL proxy, I get some CA to issue me certs for google.com even though I'm not google.com? If they do that, I can now see Google without touching any clients, right? So if I somehow get my hands on a google.com or gmail.com or facebook.com cert, even though I'm not Gmail or Facebook, et cetera, and it's by trusted root CA, the whole world's going to trust it. Now I can inspect Gmail without actually touching a desktop. Some SSL proxy appliance creators have done this. They've issued certs for things they didn't own, right? French government got caught doing that, right? Some governments like Malaysia are also CAs. I have no problem with Malaysia or Malaysians, but am I going to trust some other country's certs issued by the government themselves? You know, it could be Australia, it could be Canada, it could be anyone. I'm not comfortable with that, right? I'm not picking on Malaysia, right? So we don't have an encryption problem, we have a trust problem, right? That's the issue, right? That's why certificate pingings come out, right? So it has to be trusted, and pinning is important as well. You also want to use fairly robust ciphers, right? Fairly robust ciphers meaning strong in this case, right? The stronger the better. If you can only force TLS 1.3, that's pretty secure, right? If you have older legacy stuff, you're going to have to support older stuff too. And I can tell you from the hospital chain perspective, when I try to configure some of these ciphers, yeah, I went to like, Qualys Labs SSL scanner. My corporate website was like a D- or something. It was so embarrassing. And I was trying to enforce better security of the cipher choice, and I started breaking all kinds of old crud. You know, Windows XP is still common in those environments today. Windows NT still existed when I left that company, right? You have legacy stuff. It's just so, if you work for a power plant, you probably can't do much on this front, I'm just in my experience. I've seen Windows 3 running, Windows 3.1 running in a power plant recently, yeah. So that's where you kind of fall down on this. For normal stuff, you're fine. We have an Mmap scripting engine script that'll check. Now, as a due diligence step, I do this for my clients. I tell them, listen, your least strength is C. You probably want to boost that up. And the client inevitably says, well, did you hack the server? Did you hack it? You didn't hack it, we don't care. I'm like, no, I didn't break your encryption. Well, I don't care. It's like, well, you shouldn't be allowing very weak encryption. Now, on a scale of 1 to 10, is this a top finding? No, it's not. Let's be honest, it's not. But it's a finding. Like, maybe not critical, it is a finding, right? Company I was working for was a security company, and they got a D- on this check. So I went to Qualys Labs, a client. They sell security stuff. D- on the score. And I said, it's a finding. You're well, did you hack the web server? Did you break the encryption? Like, no, I didn't build some cluster of like GPUs. I didn't do that. Well, we don't care. I'm like, the whole world can see your grade's a D-. You're selling security features. You should be embarrassed by this. And I've successfully shamed the CIO into forcing his employees to fix it. I'm like, you should be embarrassed. Anyone doing business with you can see this. And why are you the experts they're paying a lot of money to when you're a D-, right? But did I actually break the encryption? No, I didn't. You could, in theory, if it's an older one, but in that case, I did not. SANS got an A+. I'm not surprised to see that. So the question is, I've heard that too. TLS 1.0 and 1.1 they're going to be removing support from browsers. I've heard things like that. Yes. Again, Firefox is super progressive on this front. They tend to be real leaders. And when people say, yeah, but legacy, but this, like, don't care. We're gonna move on. So yes, it's gonna be TLS 1.2 and 1.3 fairly shortly, I believe, and maybe just 1.3 at some point as well. All right, folks, let's take on Lab 1.3, testing HTTPS. Now, as you know by now, open up Firefox and scroll down to here. We'll also open up a terminal, as you see there. And we're using containers now, or a container here. So containers are a way to, a simple way to have a low impact, a low CPU, low RAM way of running additional systems. Now, a container is kind of the logical evolution of a BSD jail. So we've had BSD jails for decades now. And a jail was a way to lock a process, the files a process accessed into a directory that they could not escape. So you want to run your bind DNS server in a jail, you put bind in there, you put any shared libraries it might need in there, you put any configuration files it might need in there. Every file it needs has to be inside that directory or a subdirectory of that. That way, should something achieve a remote code execution and break out of bind and get shell running, it's stuck in the jail just like bind is. It can't read your password file, etc., right? So containers are like that, but they added things like IP addresses and ports in that same jail concept, right? It's not full virtualization. It's running the same kernel as the host OS, meaning your Linux VM here. But it is a nice way to run, a low impact, low cost way of running software. A good way to avoid version dependencies. This one needs Ruby this one needs Ruby that. It's a nice way to kind of separate your software that way. And when you want to run something insecure, it's nice to have it in a container that's contained inside your host and can't be reached from the network. So hit that button to press copy, open the terminal. Shift-Control-V or Edit-Paste does the same thing. When it's ready to go, it'll say that. Now, if you see additional content, it means we updated the container. Sometimes we update containers. If you see it pulling down stuff, it means we made an update, an improvement, whatever. So don't be surprised if you see different output. This is true for any container we start, or things in the wiki generally. We may later decide, for instance, to make this image bigger. So we'll do that, all in the name of quality. So if things are slightly different than what you're seeing, that's all in the name of quality improvements, things like that. All right, so I'm going to use Qualys now. And as I said previously, if I want to keep this tab open, I'll hit Shift, open link, a new tab. And I kick off the scan to sans.org. And while that's going, I'll talk about what it's doing. And I may leave this running, come back, because it's going to take a little while. And it's always interesting to see who fails, who gets A+, who fails. And a bunch of Fs here. Sometimes you see big names. See that name right there? Now your list is going to be different. This is recent things you've seen, but that seems like a pretty big name to me. I don't know. I've never been to that site, but they get an F. So all right, submit. Oh, there you go. I tested previously. Normally it takes a little while to get there, but I tested previously and there it goes. And yay, SANS got an A+. It would have been really embarrassing if that was an F, wouldn't it? No, it's an A+, because hopefully SANS knows what they're doing. In fact, I know they do. It's very, very well secured. Now, this is a moving target. When you try SANS, a week from now, a month from now, it may change because security standards change, new attacks come out. Yesterday's A+ may be tomorrow's A- or B+. That just happened. So don't be surprised. Just like the last lab, it's live data. So as standards change and the scores get more stringent, sometimes scores drop. Feel free to check your own company's website. And if it's a low grade, you may want to tell your IT team that they should fix it. Because it is a public record. Anyone can see this. And a client of mine was a security consulting company selling security services, consulting services, charging a lot of money per hour. And their grade was a D. I'm like, you're trying to sell security services and you can't secure your own website? And there is a bit of public shaming here. I brought it up before, and the answer, and I wasn't there to hack the website, I just mentioned it. I was consulting for other purposes. And the developers or the people, the IT team was like, well, can you hack it? Did you break the encryption? And I didn't break the encryption. It's hard to do that without supercomputers. But I'm like, anyone can see that. It's a little embarrassing, don't you think? And the CIO got sufficiently embarrassed that he made them fix it. So there you go. You should walk the walk and talk the talk, not just talk the talk, right? All right, so A+ for SANS, that's good. Feel free to test other websites. Now, Qualys is great for public-facing stuff, but what if it's internal? What if it's an internal site? Now, Qualys does sell an appliance you can bring in and do the same thing, but that's, it's a good tool, don't get me wrong, but it's expensive, and it may be faster to use a tool like Nmap, right? So we did the solution here. We've already seen that. Again, don't be surprised if that grade's different. And now let's test the configuration of sec542.org and heartbleed.sec542.org. All right, so we've already run that command. No need to run it again. And we have it in both places in case you want the no hints method. So I'll run the nmap command, and I'll walk through what this thing's doing. Have to open a new terminal. Leave that one running now. Don't Control-C that. Open a new terminal. And least strength is an A. So it gets an A, and I'll show you the command, and I'll walk through the command a bit. So we use the NSE, that's Nmap scripting engine, SSL enum ciphers, and we said save the output to www.sec542.org.nmap/temp, and I'll actually show you that file. That's in the Nmap style output. So Nmap is readable output. There's also XML output. Let's look at that. The lab didn't have you do that, but why not? Little bonus step here. And, oh, wrong one. I want to copy paste that. Just that, not the whole command, just that. Yeah, here we go. And same output you just saw, basically. So now you have that for future reference. If you want to input the data into something else, you can use XML output, and I can show you, you can do a man page. Yeah, -OX is for XML. And what I just did, I typed man nmap, hit a slash, typed XML. I was pretty sure it's -OX, but I wanted to be clear. Sure. And we did normal or nmap output previously. You can do XML, which is good for ingesting into other tools like Metasploit, right? Things like that. All right, so we had a least strength of an A. Now let's do heartbleed. And since heartbleed is a big flaw, you might imagine this score might be a bit lower. Least strength's a C. So the weakest cipher is a C. And the lab actually has some details on why it's choosing these. Yeah. If you're wondering why it's choosing the scores it's choosing, it's a pretty complex discussion. There's lots of reasons why. And Qualys has this whole big list of why certain things get certain grades. In case you're curious why a certain cipher is dragging down the score, why is this guy here a C, you can research that stuff. It's beyond the scope of the lab. But if you're curious, many students are, research that guy. So www.sec542.org is more secure than Heartbleed, or has more secure ciphers than heartbleed.sec542.org. That's hardly surprising given the names of the software they're running. And finally, stop the containers. It's not a big deal if you don't. It'll just lower the resources, the CPU, whatever, and the RAM of your system, because you don't need that right now. We'll start and stop containers on every lab. And you can only run one container at a time. So if you left the container running, and then a later lab started another container, it would actually stop that container and start a new one to avoid any dependency issues or conflicts. All right, that's lab 1.3. Thank you.